Welcome to the sixth video in this video tutorial series about how to run simulations of federated learning workloads using the Flower framework. In this video, we're going to learn how to make your client apps stateful, because by default, client apps in Flower are not stateful. Whether you are doing simulation or you are using the deployment engine when you want to run these apps out there in the real world on real devices, it's important to be aware that client apps need to implement some mechanisms so metrics, intermediate results, or even model parameters can persist over multiple rounds. So this is a topic we're going to cover in this video. I will be showing you how you can achieve this kind of persistence in your client apps. And this will be a mini introduction to what we will be covering in the next video, where I will be presenting a high-level view of how actually Flower simulations work. So without further ado, and before we look into the code, let me point you to the Flower documentation, because in this video we're going to follow the guide that is presented in the Flower documentation, and we're going to see how to take some of those code snippets and make use of them in the Flower app we are developing in this tutorial series. So to get the documentation, it's pretty straightforward. If you go first to flower.ai, let's go to the documentation button, then click on Flower framework. And here you can see a long list of resources, including tutorial, quick start PyTorch, and many other tutorials for other frameworks. And if you keep scrolling down, we'll see there is this how-to guide, design stateful client apps. So if we click on it, you will see that it's fairly detailed, providing background of why client apps are not stateful, which means they are stateless. And it will walk you through on how to save different type of data structures into the state, which is what we are going to be doing. So, but before we jump into making client apps stateful, let me show you that by default they are actually stateless. So if we go to our client app file, for example, let's say that we want to store in a list, in a standard Python list, we want to store the training loss of every round this client app is going to be participating in. So the typical way you would do that, for example, could be something like this: self train loss history, and maybe we will initialize it as an empty list, right? And then after every time we compute it, we will be appending a new entry, right? This is one way that doesn't sound too, it sounds like it should work, right? So if we, for example, print this, we should see that after every round, this client participates in, the list will become longer and longer with each participation adding a new training loss entry. So let's see if that is the case. And as I have already hinted, this is not going to work. We'll see it's not going to crash, it's not going to throw an error, but what we are going to see is that this list is always containing one element. And you can see it here, each client is printing their result. And why is there only one element? It is not because clients are only sample once in the entire experiment we are running here, 3 rounds. No, it is not because of that. It is because every time a client is being told to participate in a round, whether it is fit or evaluate, every time that is going to be spawned by the simulation engine, and we'll see a bit more details how this works in the next video. Every time that has to be done, this object is constructed. So this means that, yes, every time the client with client ID 4 or the client with client ID 3, this client function gets executed. Naturally, this process doesn't take that much time after running it for the first time because the data sets get cached and everything's pretty fast, but the object, it is created and destroyed each time. And that is why we cannot persist lists or any other data structure just by doing this. Instead, what we can do, and that is what is explained in this guide we're going to get back to very soon, is that we need to make use of the context. Because this context object, it is unique to each client app instance. So when the simulation engine install client number 3, you're going to participate in this round. The client number 3 is going to get a unique context object, unique to itself. And that's why, for example, we were able to use the context to extract what is the partition ID of the client app that is being created. So everything we want to persist, whether they are intermediate results, metrics, or some model parameters that we don't want to communicate with the server because they have to remain private, for example, that should be stored in the context. So to enable this statefulness, we're going to pass the context, the entire object. So we're going to pass it, it's going to arrive here, context of type context. And if we inspect the context by doing right click, you can see this in the documentation, but now we are in VS Code, it's sometimes easier to see it in the source code. We can see it has different parameters. And what we care about is this, the state, which is an object of type record set, that we are going to talk about it very soon. So what we're going to do is we're going to call it client state, and we are going to just like that. So now the client state is going to be accessible from all the methods in our client. So just as a short recap, now here in client state, we have the state object inside the context. That is a data structure that is guaranteed to be persistent across multiple participations that this client app is going to be taking part on. So let's go back to the documentation and we can see, for example, this is a tiny example showing pretty much the same thing I demonstrated to you now that it's not possible to store variables by just appending them to a standard list. And what we're going to do instead is we're going to initialize the context. In particularly, we're going to initialize one of the different types of data structures supported in the context that is called configs record. You can read more about the configs record here in the documentation and also about the other types of records. So let's remove this because this is not useful, and we're going to copy. And we're going to call this fit metrics because we want to make use of this in our fit metrics, and I think it's more relevant to save it like that. So what we are doing here is that if there is not a fit metrics inside the config records of our state, we are going to create it, and it's going to be an empty configs record. Let's take a quick look into how the record set is constructed. So if we see here, the state is an object of type record set. And record set, if we go into the definition, the record set, you can think of it of a fancy Python dictionary that has 3 types of dictionaries inside of it. Sorry, let me backtrack. You can think of it of a fancy data class that has 3 elements, each of them being a fancy version of a Python dictionary. So the idea, there are 3 types of records. Parameters record, which are intended for storing parameters, or more generally arrays of data, like NumPy arrays, PyTorch, TensorFlow, it doesn't matter. Metrics record, which are designed to store metrics. This is very similar to the metrics we were using when we were looking into these callbacks from the strategies. Metrics have a restricted type, a restricted set of types that are supported. And finally, we have the config records, which extend the set of types from metrics record. You can find all this information in the documentation. And for the purpose of this short tutorial, we are going to just focus on configs record because these are the ones that offer the most flexibility. So this is exactly what we do. We have our client state and we want to add a new configs record. So we go to our configs record dictionary and we insert one under the fit metrics key. So now if we go to our fit method, remember what we want to do is to persist all these train losses across multiple rounds. So let's first remove this because this is the old code we had earlier when we demonstrated that in fact client apps are stateless. And what we're going to do is go back once more to this example here, and we can build on top of what's done over here. So let me copy this and we will make some small edits. So what we are doing here is just accessing the client state and extracting the configs record we have created. Because we changed the name, let me change the name again. And what we can do here is, for example, the configs record themselves are also a special type of dictionary with only a predefined set of allowed types. You can see it here, it's like a dictionary, and the types that are allowed is, for the values, are config record values, which if we inspect it, you can look this on your own time, but basically it's an extended version of what is allowed for scalars. So what we're going to do is we are going to first not give it this name because it's not very meaningful for us. Instead, we're going to give another name, train loss history. I'm going to use it like this. And then if training loss history is not present in our configs record, we are just going to add it. And if it is already present, which will be the case the second time the same client app is participating in the experiment, we are just going to append it to the existing list. And now, just like before, if we print, for example, if we print the state of our state, just like this, what we will see is that the first time it's going to be empty, there won't be any training loss, but as the client participates in subsequent rounds, we'll see that the training loss history key gets populated with more entries. So let me clear that and let's run it. Just as a short recap, the only thing we did was to pass the context and store some data in the context, which is the object that persists across multiple participations of the same client app. And you can see here, every client is, here we have added this print statement. So every client is printing its entire state, which is of type record set. As we saw earlier, the record set has 3 types of data structures: parameter records, metric records, and config records. What we decided to do was to create a config records under the name fit metrics, which is created here. And then each time the client runs its fit method, it will create a new dictionary inside under that fit metrics key, adding the training loss of that round. And subsequent executions of the fit method for the same client app is going to add more entries to that list. So what we see here is that, well, this client app is the second time it has run the fit method. So we see there is already 1 entry. Why don't we see an entry here? Because that's the first time the client is participating. Recall that our feed rounds are not sampling all the clients every round. They are sampling only half of the clients. If we go to the third round, what we can see is that, well, there are some clients that don't have any information here when we display it here, because this is the first time they participate, but other clients, for example, this client has been participating in all the rounds. So we can see here what was the training loss in the previous 2 rounds. If you are not able to see all these logs in 5 individual lines, you might want to export an environment variable that is something. You should do it just like this. This is an environment variable that used by Ray. Ray is an open source framework that the Flower simulation engine uses under the hood to parallelize the execution of the client apps. That should, once you have executed this, which you can also put in your bash RC or your ZSH RC, you should be able to see the logs just like I see them. And if, for example, I run it again, but running for 5 rounds, let's say, we'll see a similar behavior, but because we have 10 clients, sampling 5 per round, and we are going to do 5 rounds, it is very likely that, well, it is much more likely that all clients will at least participate more than once. So let's see if that's the case. Now we're in the 3rd round, 4th round, and the 5th round. Well, we can see here that this client participated in all the rounds, others participated in 3 rounds, and, well, surprise, surprise, this client never participated. Well, only participated once, but that's okay. Here we are only saving a very simple metric, which is the training history. This is something you could, for example, use if you want to adjust at runtime some training hyperparameters. You would say, oh, the training loss hasn't been going down in the last few rounds. Well, maybe it's time to decrease the learning rate. Maybe that's some type of analysis you want to perform here and decrease the learning rate and other hyperparameters. And you can, of course, do more exotic things if you wish. We are saving only a simple metric, but you could save other more complex data structures like, dictionaries like this, or you can also save parameters directly. Here in the documentation, I show you how to use the parameter records, which is a different data structure inside the record set, designed for storing parameters in the form of NumPy arrays. But you can really use it for saving PyTorch parameters or anything else. So follow the mini tutorial here in the documentation if you want to know how to do that. It is shown how to do it with PyTorch, but with TensorFlow you would follow exact same steps, but only making small changes when you have to interface with your machine learning framework specific APIs, like those in TensorFlow. So this is everything we were planning to cover in this tutorial. Making stateful clients is important when you want to make use of more exotic training algorithms or evaluation protocols in your client apps. It is also important if you want to do things like federated personalization, where, for example, the first few layers of your model get trained in collaboration with other clients, like a standard federation, but maybe the last few layers, the output head of your model, must remain local, because that's where the personalization happens, and maybe because of some privacy concerns, you don't want to share that with the server app. One way of achieving personalization in that scenario is to persist the head of the model in the context of the client app. And now you know how to do it. We saw a simplified version of how to achieve that in the video tutorial, and you can find a complete way of doing it in the documentation. In the next video, you will learn how the simulation engine works, and we will start scaling up our simulation. So far, we have run with only 10 clients, but there is really only a very small change we need to do to run it with 1,000 or even more clients without having to change our workstation. So get ready for the next video, and I see you soon. Bye.